Hi, good afternoon, everyone, and welcome to our webinar. It's called Floating PV and Extreme Weather. Hi, Paulina. Thank you for joining us. Um, yes, you
Hi.
can turn off. Yeah, you're gonna. So Paulina will join us at the end for maybe the Q&A session. So Paulina, if you can turn off your camera and your microphone, and then all of you will get to see her later as well. Perfect. All right, so you guys got a sneak peek into one of the speakers joining us later. But yeah, so this is our webinar, Floating PV and Extreme Weather. We have a really interesting webinar coming ahead. So this webinar will be in the lead up for our Solarplaza Summit Floating PV conference in Europe. And we really look forward to it and to welcoming all of you. My name is Dee. I will be hosting this webinar, and I come from Solarplaza. And our goal is to, impact the world in a positive way by accelerating the energy transition. We are now 20 years old, which is super cool, and we hold solar conferences all over Europe, even worldwide. Cool. So practical notes. You're joining us here in our webinar right now. If you have any questions, there's a question box to the right of you over there. It has a little question mark. Please, whenever you have a question, put it there. We will collect it, and the speakers will answer them at the end of the webinar. Any technical issues, please use the chat box as well. We will help you out, and the full webinar recording will be available at the end of the webinar. You will receive an email in about 1 to 2 days, and then it takes you to a link to a private YouTube link, and you can watch all of it. All right, so floating PV and extreme weather. Lessons from the field and resilience for the future. So what is an extreme weather event? Here, I think we define it as an event that is rare at a particular time, place, or time of year. So it's very unusual in terms of magnitude, location, timing, and extent. These things that were once rare are now becoming a meteorological norm. Flooding, storms, rapidly fluctuating water levels, these are all things that happen, now part of the day-to-day life in climate change. So there's a strong need to currently forecast, build resilience, and adapt to this extreme weather. And we hope this webinar will be your entry point. So today we will learn from two experienced players. We have Qussay from HelioRec, as well as Andrés from Isigenere. They will share their experience here in the field and their work and experience in developing robust, future-ready floating PV projects. So we will begin with Qussay. And this webinar will be in the lead up to our event in Paris. We hope that you join us as well, and we will continue the conversation there, of course. Now, without further ado, I will give the floor to Qussay Jarrar, who is the Doctor of Industrial Engineering at HelioRec, and he will talk us through their experience in floating solar PV plants with flooding. Qussay, you have the floor. You may turn on your microphone and your camera and join us. And my colleague will give you control of the PowerPoint. Hi, Qussay. Thanks for being here.
Hi.
Amazing.
Yes, I hope that you can hear me well.
We hear you well. We're going to give you the clicking in a bit.
Yes, I have the control now. Perfect.
Amazing. All yours.
Yes.
Take it away.
Thank you. So first of all, good afternoon, everyone. Thank you for joining this webinar. And thank you, Dee, for this introduction. So actually, before I start this to present the slides here, I really want to raise a question that I want you to keep in your mind during that presentation, which is, can we really produce clean energy within extreme climate events? And if the answer is yes, how could we do that safely? So in fact, within the climate change accelerates, and we are seeing like more frequent and intense flooding, especially in the coastal regions. So that leads and poses a serious question and serious threat actually to traditional energy infrastructure, including land-based solar installation. Where floating solar, however, flip the script actually by using water surfaces where these systems not only save land, but also adapt to water level changes in real time. HelioRec floating platform actually are designed and engineered precisely where they remain actually stable and operational during severe floods and ensuring uninterrupted power delivery. So briefly in today's presentation, what I want to present actually is a real case from the real world application of one of our projects where we were able actually to produce clean energy in harsh conditions. So in January, actually, a couple of months ago, in January 2025, Storm Herminia unleashed record-breaking rainfall and severe floods actually that hits the region, mainly the Brittany region in France, where Rennes, the region, has experienced one of its worst flooding over the 40 years. During that historic flood, actually, our HelioRec platform, as you can see here in the red circle here, actually remained fully operational, delivering uninterrupted electricity. So that's real-world performance, in fact, highlight the resilience of our innovative floating solar technology. Talking about the project itself, so the project actually installed in Domaine Cléssac. It's a golf and a hotel resort, which is located in the region of Bruges in Brittany. The platform is 250 kilowatt, which is divided into to supply restaurant and the hotel of that place. The project was commissioned in 2024, last year in October. As you can see, the platform here in this beautiful photo, the platform is consists of the power plant with the floaters and the panels and the walking path and the access bridge and also floating electrical equipment, which include AC boxes, DC boxes, and inverters. So talking about the performance actually of that platform within the storm that we mentioned before, in fact, despite of that severe floods, 2 meter, like as you can see here, like 2 meter flood on our platform stood strong. And like as we can see in this photo where the side gate is fully submerged with water, yet our floating solar power plant continued to produce energy without any interruption, and in which performance like remained stable throughout that storm. So I want to really now talk about the main key technical features that allow us to have this performance within that storm. But before I go to that thing, that already played a good role in the resilience of the system. It's important to mention one important thing and give the essential credit actually that belongs to the proper design of the floaters themselves, where in fact our floating solar system is certified from the approval in principle certificate by Bureau Veritas, and also the main component and the subsystem of our floating plant is following the recommendation practice from DNV. Coming back to the key technical features, so one of the main key features is the environmental and site assessment before doing any project, which is the meteo data analysis. So in that specific project, actually considering Eurocode with 25 years return period, the fundamental values are assumed for the basic wind, the ultimate limit state of wind speed, snow load, and wind load are as shown here in this slide, where in fact these conditions are needed and need to be taken into consideration within the design phases, within the design phase for like load analysis, mooring design, and buoyancy verification. The second key feature is the mechanical design of the platform. As you can hear the schematic that I showed to you before, here it's a top view of the plant where you can see the arrangement, which is 8 dual rows of floaters and 31 columns, which are split into 16 columns on the west side and 15 columns on the east side of the plant, which are separated with one column of big footpath. So moreover, the external here, like the external rows and column have also been designed by using the footpath, the walking path, in order to increase the stability of the plant. Moreover, the taper that you can see here, which is from the plant itself to the access bridge, this tapered transition has been chosen in order to strengthen the structure and mitigate any excessive lateral-like forces. Another important point in the mechanical design is considering the output, based on the output that I've illustrated before from the metadata analysis, where load analysis has been carried out using the CFD analysis in order to understand the total load of the system and the total load that will be subjected to. Okay, so the additional of all forces, in fact, just to show you here through the lines. So the additional of all forces acting in a single direction across the plant is equal to the addition of the individual forces in each column. So for example, here, just to give you an example, like for the total load acting on from the north south of the plant is almost 58,000 Newton, I'm sorry, including the forces that also include the forces on the access bridge, which is 2,800. And more like similar analysis was done for the east-west, west-east, and also south-north. And following that, 36 ground anchors were distributed across the north, south, and east border of the lake, as you can see here in this schematic that illustrates the position relatively to the plant. So as you can see here, for the west-east direction, in fact, there was a small incidence of winds in that direction, which is almost less than 4 to 3%. And the fact also that we didn't position any mooring anchors, that the lakes didn't have any border. So on its west side, that meaning that the potential or any possible loads in that direction are taken into account by the ropes north and south borders with an angle, you can see here. So the anchors, in fact, they were like attached with eye bolt shackles on the top of each anchor, so they support attaching the mooring ropes. And also on the platform side, as you can see in the first picture, on the top one, there are like 36 ropes loop with a 12 millimeter were placed on the platform, crossing the ear of 2 footpaths, and where the 2 ends were like attached together or linked together with 1 shackle. And the rope to link between the 2 sides is set with a thimble from both sides and clips to hold the rope itself. Another important point, which is the buoyancy check, because it's an important of the system for the system integrity verification. So mainly considering that, and since we are considering having the electrical protection floats on the plant, but generally the simulation have assumed like a downforce resulting from wind, snow load, dead load as well, shows a positive net of buoyancy for our component. Okay, for both like footpath and floaters, we have 333 Newton and 22 Newton respectively. And assuming a column, so we can say assuming the column on the assembly being composed of 16 floaters, 9 footpaths, will result with a net buoyancy of almost 6,500 Newton, ensuring that system integrity at the worst case scenarios will remain intact. It was also to run like for that reason, similar like analysis were done on the shelters that host the inverters and mounted on the footpath, considering also beside the wind loads and other loads, considering the weight of the footpath, the shelters, and the electrical boxes themselves. And as we can see here, the example that I showed here in this presentation for 2 types of inverters with their weight, the weight of shelters, the weight of footpaths, they were like stacked in on 2 stacked footpaths, where we get a positive resulting force of 364 Newton and 452 for the other inverters. So that confirmed that the double stacked configuration of the footpath are sufficient. Okay, another important point we can say, since the platform itself remains performing well during the storm, we didn't have any interruption for the electrical components. So where all the conduit, in fact, were grouped and organized, start of the bridge, they are like then divided into two sections for the left and east side of the platform that supply different, the hotel and the restaurant supply. And also the AC cable themselves were like passed to the platform on both sides with a conduit AC, that with one yellow buoys here, as you can see, that are important to like meet different tide or different levels that we'll face. So that's it from my side. I would like really to thank you all for listening and joining that webinar. Thank you.
Thank you, Qussay. So next up, we have a presentation by Andrés. Yes, he is the CEO of Isigenere, and he will talk us through how to engineer for resilience, how we can prepare our floating PV plants for climate uncertainty. Andrés, you have the floor. Perfect. And my colleague will give you the mouse control. Andrés, we cannot hear you.
Hello, hello. Can you
Perfect.
hear me now? Okay,
Yes, we can
good, good.
hear you. All right,
Okay,
let's
and
go.
thank you, Dia, and thank you, Solarplaza, for the invitation to share some of our experiences and best practices around the engineering of floating solar plants. Today, I wanted to start giving you a brief overview of Isigenere. We have been in the floating solar business since 2008, and this is the first plant that we built in 2009, a 300 kilowatt project that is still operational and that we have learned a lot from almost 16 years of experience. Yeah. And I will talk about some of the climate uncertainty that this plant has faced and how we are solving those in the new designs. As a company, we are a Spanish company that is doing the engineering and development of our product that is called Easy Floating. It's a floating solar structure, and we have already used this in different type of reservoirs. We mainly work together with our partners, that could be engineering companies, installers, to build the floating solar project. So we are building an ecosystem of companies that will bring the benefit of floating solar to the end clients, working together with them and complementing each other in the expertise that every company has. And in our cases, the specialization in floating solar structures and the anchoring and mooring solution for the different projects. Here you see example of some of the projects that we have built. What it's interesting to see that in different type of reservoirs, we already have more than 100 projects in 5 continents, and the project has faced different challenging conditions. And as Dee said, it's amazing to see what's happening with the climate. And even though in the past we are every year breaking historical records in wind speed, in water level variation, in waves, and it's important to understand what is the level of risk and how we can do things to mitigate that impact. I don't think it's possible to completely eliminate, because weather is showing us that it can be very, very extreme, but at least we believe there are several things that you can do. And you start from looking at what's going to be the complexity of that specific location. And it's important to understand if the plant and the reservoir that you're going to build, it's in a really challenging condition, or it's more type of the standards. And you need to look at things like water level, the winds, the flooding that was mentioned, the snow, because all of that is going to put pressure, fatigue, and can create challenging conditions for the floating solar plant. And today I want to share our experiences mainly in 3 uncertainties that the floating solar plants can have. So the first one is the water level variation, second is the buoyancy, and the third is the fatigue of the components. So let's start with the first one on water level variation. And water level variation can look in different ways. This is a first picture of a project that, okay, yeah. They have a project that the owner of the pond had told us that the water was never ever going to go lower than the black part that you see on the top. Uh, and well, yeah, for several years it didn't go lower than that until significant and extreme event happened, and they had to use the water, even though it was regulated. They had to use water for human consumption, for crops, and the water level went lower than expected. And in this case, the system was able to adapt, and it's flexible enough to bend in the slopes, even on top of the tubes of entrance and exit of the water. Water level variation can even more extreme, like in this example where there is almost no water at the bottom. In fact, you can see that there are bushes around because this plant has been with very little water for several months, and there's already vegetation growing. And the bottom of the reservoir is not completely flat or clean. It has a lot of mud. So you need to design in a way that when the water comes in, the floating solar plant will be able to again go up, and that the anchor and the mooring will help to do that. And it can become even more extreme. The next picture is a picture of a floating solar project that ended up being a ground mounted project. And this is in a dam. And again, in this dam, this broke all the historical records. There was even regulation again on the minimum water level of the dam. But nature will go against any law that humans have put on a piece of paper. So it's important to find solutions to manage these type of situations. And what is the first recommendation to cope with significant water level variation is the use of elastic mooring. The picture that you have in the back is a floating solar project in Portugal where we are facing water level variation of 30 meters. And you need to design the plant so that it will be able to cope with the wind loads, the wave load, the current loads in a way that the plant will not receive the mechanical stress. And that's why we are using elastic solutions in conditions where we believe there could be significant water level variation. We are working together with Cflex. And the benefit of this type of solution is that the mooring lines with the water level variation will always be in tension. There is no slack. And that is relevant to prevent the slack because when you see a system that has a slack, for example, here, a traditional system on the left, when water level goes down, there is a slack, and there is more movement on the system on the left than on the system on the right. And what happens? Well, the situation is that the system on the left will create more mechanical stress on the components compared to the system on the right that will absorb it in a gradual way. So the use of elastic mooring dissipates those mechanical forces and increases the longevity of the components. And this climate change uncertainty, especially in water level, can also happen during installation. You never know what's going to be the water level when you are doing the installation. You cannot control it most of the times. So if you cannot control it, you might end up in a situation where you need to build expensive platforms that you're only going to use once. And this could cost tens of thousands of euros. The one that we saw that it cost the most was in a project in the US that was almost 90,000 euros for the launching platform. And that's only going to be used once. And then you're probably going to need to not be able to reuse again the components. So you need to be able to have a solution that somehow can be flexible, that the structure doesn't need to have a minimum entrance of a slope when the floats are going into the water. And we have found a solution where we are attaching our floats with flexible joints that are made of fiberglass and nylon. They can almost bend to 70 degrees without breaking. And this was also very relevant for the fatigue related with the waves. And in this case, it was a plant installed in Chile where there was almost no water. You can see the bottom of the reservoir, and they had to use the water. It was more important for them, and we were still able to launch all the structure and bending significant because there was almost 10 meters of depth in this reservoir. So we talk about water level variation. Let's talk about buoyancy. Buoyancy is already a challenge in floating solar plants. So you can see here example of just people walking in the floating solar plants, and imagine what happens when you get snow loads. And also Qussay showing the project that they had more than 40 kilonewtons per square meter and snow loads. So this is becoming a very relevant issue. And you don't want workers to be doing maintenance and changing electrical equipment while they are touching water. So it's important to design at the beginning with bigger floats so that have higher buoyancy. Here you can see how 9 people can be working one right next to the other, and there's still a space between the maximum level of the float and the water. So it's important to design with enough buoyancy. I know that sometimes there's a lot of pressure from the clients to reduce capex, but it's important not only that the capex is efficient, but also that the opex will be efficient and also safe for workers. And if you don't have enough floats, well, probably it's not going to be very easy. And what happens when the snow arrives? And this is an example of a plant here in Spain, close to Madrid. You have in the image, well, Madrid, very sunny, blue skies, not a lot of snow, but it was 3 years ago that we have a severe snowstorm that hadn't happened in the last 20 years. And this plant accumulated almost 50 centimeters of snow. And given the design that we have done with the plan, the buoyancy, the plan worked perfectly. There are other places where you can believe, well, like this picture in Germany that usually accumulates snow, and you might design with the basic snow load of the Eurocode, but the fact is, again, that there are records that are being broken, and you need, again, to design taking into account that big uncertainty with climate change related with the snow. And how do we do that? Well, the first, we have different type of float design. So in the left, you see our standard design where every PV panel is supported not by one, as mm, in certain floating solar plant, but by two floats. So this already gives you an idea of the higher uh, buoyancy that the system can support with heavy snow loads. But in places that we know that there could be even additional snow load, what we do is reinforce the design. And if the standard design can go around 60 kilos per square meter of snow, with the reinforce, you can go to more than 100 kilos per square meter. So in this case, you have an additional flow that is below the PV panel, and it's very, very more resilient from a snow load perspective. So in the design, what else do we do? Well, for the snow, it's important that snow is just a buoyancy issue, and this is physics. So the more snow, the more flow, the bigger the flow that you need, because this is Archimedes' principle. So you need to do it in a way that will be able to sustain that extra load. Our recommendation is that you do your own calculations on what should be the net buoyancy of the system, that you start calculating the gross buoyancy, taking into account different type of floats, how many do you have in the system and what the buoyancy of each of those floats. You can add the total buoyancy and you get the gross buoyancy. Then you need to deduct the weight of elements, for example, the PV panels, also the floats and all the metal components that are supporting the PV panel to get the net buoyancy. And when you deduct that, you have the net buoyancy, and then what you need to do is divide the surface that the plant is taking by the net buoyancy. And then you get how many kilos per square meter you're going to be getting for the plant. So it's important that you make that calculation, that you include the safety coefficients together with the engineering company or the float supplier company to make sure that at least you feel comfortable that the plant will be able to manage certain extreme events. So we have talked about buoyancy. Let's go to the third, and the fatigue and the loads on the components. It's true again that weather is becoming more extreme. The Euro code for us is a reference, but usually, even though the Euro code in many places in Europe says that maximum winds will be around 100 kilometers per square hour, we have seen plants that are facing 140, 150 kilometers per square hour in extraordinary events. So how are we coping with those situations? The first is try to do a system that will be as aerodynamic as possible. And what we are doing is we are reducing the tilt of the PV panel. We started 16 years ago with 10 degrees, but now we are at 5 degrees. And also we have closed the back of the PV panel with the float, with the structure, so that when the wind hits, it's not hitting in a sail. The PV panel can become a sail, but it's hitting in a wall. So when you compare that to other configuration at a higher tilt, and especially when the back of the panel is open, the CP factor that the engineers calculate gets reduced a lot. So a 5-degree closed canopy, it's about 0.48, and in this other configuration, it will be 2.1. So we're talking that just the design can increase the wind load by more than 400%. So this is increasing a lot the forces that the structure will be suffering, and it might not happen only once, but it's going to be more than several times in the 25 years of the plan. The next item to keep in mind, it's related with the fact that the wind will create waves. Depending on the fetch of the reservoir, it can be small or big waves. But even the waves that are 10, 20 centimeters, they can create fatigue. In this video, you see this is a lake that is not too big, but when you have light winds, you see all the movement that is already happening in the floating solar plant. And this can create significant fatigue in the elements. And we believe that it's important to try to disseminate, to dissipate the mechanical stress and not to absorb them. We have been working with institutes that are expert in waves, in analysis on the different type of situations. And this is the type of testing that we have done where we have put the system to high waves, but also high frequency waves, because when you have one wave coming right after the other, that's when you see the fatigue effect in the materials. And that's also why, as I mentioned, we have flexible connectors between the floats. So again, you can see the floating solar plant is kind of surfing the wave. It's not absorbing the mechanical stress, but trying to dissipate that stress. And sometimes, if the waves are not too big, you can manage with configuration with extra floats. But if the waves are significant, like in this case, in a plant that the design parameters could be almost 2-meter waves, you need to include additional components like breakwaters. So you can see here on the upper part, there is these are not floats, this is a pontoon that has the possibility to break the wave and reduce, you can reduce the wave effect. And it's important not just to talk about the large waves, but also the smaller waves, because even with the wave breaker, I'm playing the video again, you can see all the movement that is happening inside. So this is very relevant in dams, in big lakes, where the fetch is long and you might need extra protection to eliminate the fatigue effect in the components. The other part that is relevant is testing and doing a lot of tests, because yeah, you can install it in complex projects, but it's important to make sure that you have tested with a lot of cycles of fatigue. And we have developed uh, our own benchmark and testing tools so that we can simulate complex situations like this one with waves. Here we're simulating 1-meter waves, waves with 2 seconds of frequency, and we are doing this for 48 hours. So we are looking what's happening in all the components, and after the test, we will retest each of the components to see how they are behaving for strength, and tension, and all the key components and key variables that you need to make sure that the floating solar is working correctly. So these were the three main topics that I want to discuss about water uncertainty. Please keep in mind that as the weather is becoming more extreme, you need to think about some of those issues and how you can reduce the impact. And we are very open to continue the conversation with you to make sure that you have very successful floating solar projects. Thank you very much for your time.
Thank you, Andres, for your presentation. And now we're going to move on to the Q&A section. So I welcome Qussay. You may turn on your camera. And Polina, if you'd like to also join us for the Q&A session, please turn on the camera as well. Amazing. So as always, should there be any questions here in the audience, please send it to us in the question box and we will get to them. We have around 10 minutes and we will get to all of them. So I wanted to start off with maybe a question from me. I'll sneak in there. So we talked about all these new mechanical design adjustments and additional components. And I think one thing that's missing is we always need to think about the business case when it comes to maybe building these projects. So maybe you can elaborate on the calculation, or not maybe not in detail, but could you share a bit more about the impact that these adjustments have on the overall financial picture for the project?
Okay. So you are asking me, and not
one after the other. Maybe Qussay, if you want to go first.
Okay. So I can say that the business actually case is centered around the most important things, just to have a long-term performance. This is, we can say, one of the main factors. And also it could be some risk reductions, like based on what you have seen, where when we placed all the electrical boxes, they were not placed on shore, they were placed on the platform itself. So we will reduce any risk of having any problems with those electrical boxes, any interruption in power delivery. And for that, we have done like a buoyancy analysis, as I have shown in the slides. And we have shown how those criteria, or how those calculation were based, and using like different kind of buoyancies. I have noticed, I've pointed here some kind of static equation using using SolidWorks, and we have some dynamic calculation using different like CFD softwares like Archiflex.
Thank you. Andres, does the same apply for your considerations too?
Well, you were talking about what to take into account in the business case, and I think it's also a collaboration and a dialogue with the client, because we don't know and nobody can forecast what's going to happen in the future. It's true that if you increase safety coefficients, the cost of the plan will be higher. So what we try to do is sit down with our clients and look, there are certain things that we really recommend that you be more conservative. For example, as I mentioned, the wind loads, not just to take into account Eurocode, but have additional. On the water level variation, we show them these examples of floating solar plants that have gone lower than expected. And as Qussay also showed, it can go higher than expected as well. And to make them realize that this can happen, and it's not just about trying to have the business case with a higher return, because it's very relevant that the floating solar plant will work well for the 25, 30-year period. And give them the option. Say, look, if we go for this type of solution, this is the extra benefits and the extra security that you're going to get. So very similar to when you are trying to buy a car, you can go for the basic car, or you can go for a more reliant resilience and that give you higher service. So it's important to have that conversation with the client, that there are different configuration, that is not a one size or one configuration fits all, so that they will make their decision on what level of comfort and security they want to have, and they can translate that to the banks or to the insurance company that will be financing the project.
Thank you both. Thank you for the answer for this question. And now we've just had a host of questions come in. I think we have about 10. So let's take one from, oh, where did it go? Of course, from Yuhan. So they ask, they found the discussion on extreme weather impacts really interesting. In addition to snow, to both Qussay, Andrés, and Apollina as well, could you please share how you address the issue of lake ice? And whoever would like to take the question on how you address lake ice may start.
Okay, I can start. Well, lake ice again, it's something you need to look at that at the beginning of the project. And I believe in general, floating solar is more complex than ground mounted or rooftop. So not just because you see nice piece of water, that means that it's great for a floating solar project. You need to understand what are the limits. We had a client that wanted to put a floating solar project in a lake that had 40 centimeters of snow. We said, no, we will not design for something like that. Because if the icing happens very quickly, you have seen the boats, and we have in our floats also a design that there is an angle. So when there is the pushing of the ice at the bottom, it will take the float up. But if the icing happens very fast, yeah, it can get stuck, as it happens with boats that sometimes get stuck with the ice. So we look at the ice to understand what is the height of the ice that can accumulate in the historical record, and also the speed where the ice can get created. Yeah. And depending if it's too challenging, we will say that we will not work on such extreme conditions.
Thank you. Okay, does anyone have anything else to add?
HelioRec, we had experience with ice in Russia. So I think the most important to perform lab tests with the floaters with several cycles, freezing, unfreezing the floaters, and make sure that the several cycles can sustain. This is what we did. And just to add on the previous question, I think the most important is to educate industry and make sure that insurance company will give insurance for the project for extreme weather. I think it's important for all the project developers and the technology developers to share experience and make sure that we mitigate risks, educate insurance company, educate the clients, and in this case, all the financial risk can be reduced as much as possible.
Thank you. Okay, so next question. Which is better for stability, many smaller modules or few large modules?
It depends on the design, and for lake application, obviously it's better to have modular system you can bring on trucks very easily. And if it is offshore application, for example, technologies like the solar duct, they have big platforms. So it's more complex in terms of delivery, but the system needs to be like big, robust system which needs to survive high waves. So depends on application, I would say.
Okay, depends on the application and what the requirements of the project are. Clear.
Yeah, we just want to add, it's mainly depend on also the deployment. We can say it in a different way based on the deployment side.
Yeah.
So where you can see the modular could be easier if you have more spaces to assemble and deploy. And the other side, if you don't have that space, that will be also difficult to move it and do the deployment.
Thank you. So we then move from modules to anchor cables. We have a question from Rui Lima. So how, this is about anchor cables and anchors, okay? How frequently do they need to be inspected? And what type of damage happens more frequently?
Okay, so I will give our experience on that one. Well, the anchoring and mooring, it's a whole system. So what we see that is important, the first key part is on the choosing of the anchoring. thinking on what could happen during extreme events. The use of concrete dead weights, it's very efficient from an installation point of view. But what happens when you're doing installation of concrete dead weights in a slope at the bottom? So when you have the strong winds, it might create some movement of the concrete dead weight. So you might need to go for more different solutions. It could be helicoidal, it could be other type of anchoring solutions that, yeah, I know that that will increase the cost because most of the time you need divers to do certain installations at the bottom, but it's needed because if not, when the water and the stream event arrives, there could be an issue. And you need to make sure that the anchors stay at the bottom, especially with concrete dead weight. We recommend now you have solution with robots that can go under the water and they can measure with GPS what is the location of the concrete dead weight. And this is something that anytime that there is a higher or stronger than expected wind situation in the lake, we recommend the client to check if there has been a variation in the location of the concrete dead weights. Because if that has happened, the behavior of the mooring lines will be different than the design. So it's important to make sure that after such extreme events, there is a review of the situation of the plant, and if needed, that the length of the mooring lines or other element might be changed. Regarding the maintenance of the mooring lines, if we are using, for example, the elastic mooring lines, it's not needed to do any change in those. They can last. They have been lasting in water reservoirs that have also salty environment, like in the sea, for over 30 years with no extra maintenance. So you need to find the balance on the capex and the opex in the anchoring and mooring for those extreme events.
Okay, cool. We press on with the questions. So one question we have is what are the main weather parameters you need and what period of time is good to have to start the design of a floating system? I'm sure both of you have your different perspectives. I don't know, Qussay, Polina, do you have any thoughts on this?
Qussay, you can answer.
About the time, what was the question about the time? The right time to what?
Main weather parameters that you need and what period is good to start the designs. I assume they mean construction. So but yeah.
Definitely, like depend on the region where you install the plant. For example, we have an installation in Brittany, in Brest, Port de Brest. Yep. And where actually the weather here is not stable. Like even if you do the installation in summertime, you might have some rains. But it's always good to, like based on the area, the deployment place, to try to find the most suitable like period in order to install the plant. And also before we do installation, we do some kind of water analysis. We can do some to analyze or to assist the site, as I mentioned before, like in terms of using the Eurocode or some simulations in order to analyze all the parameters needed. And in some cases, we do what we call wave sensors, wave current sensor, spotter to be dropped in the location for a period of time. And based on that analysis, we come up with ideas how to mitigate any risks in this specific deployment area.
Thank you. Andrés, do you agree?
Yeah, I would say usually we recommend the clients to first get 3 different reports. One would be the bathymetry, and in the bathymetry you need to be very careful with the potential of mud accumulation at the bottom that most of the time will not show in the bathymetry, but that can be a challenge for the installation of the anchors as well. Second report would be the geotechnical study to understand, especially if you're going to be doing bottom anchoring, what is the friction coefficient and what's the best solution for the anchors. And the third is the report on the hydrodynamic aspect. So that's the wind loads, the maximum wave that can happen on that place. And it's important to have somebody that will be an expert and can bring that expertise, not just the let's say, not just the historical records. The historical records are one input, but it's also good to have that theoretical definition. And also in certain cases, we will also recommend to have some on the spot measurements. So put in wave buoys that will also, and those 1.5, 2 year data that you collect, it's more about the fine tuning of the theoretical calculations to understand if during that period of time, what in theory happened, it's the same as what happened in reality, and to use that to calibrate and decide again with the client, okay, this is the parameters that the floating solar plant will be designed to, and if you're okay, we go ahead.
Thank you. So then we have another question. Can floating solar be installed safely on drinking water storage areas? Are there any problems related to heavy metals or microplastics or anything else that you could see coming out of the system?
Okay, so I can talk about that one. Well, we have already installed our system in several places that have water, water for human consumption. It's important to make sure if that is a concern that you get a solution that have been tested and certified. There is a British certification that the materials and the components are safe to be in contact with water for human consumption. We have most of the elements that we have and the materials, they have compatibility with drinking water. And also the metal that we're using also have been tested to be compatible with water for human consumption. So I know that this is a concern for certain companies, especially the water management companies. But I think if you make sure that you get the certificate from those companies that there is no problem.
Thank you, Andres. We have a question for you, Qussay. So, have there been or are there any IEC standards for the floating solar or components for UV and the entire system?
Yes, indeed, for sure. Like for all the, and this is what also when I presented when I show that in my presentation that the DMV recommendation is adopted in our installation, and also you can see there that in the electrical section that some of the IC standard are included. Okay, that means, and also we have some IC standard for specific electrical component because we are talking about solar systems. So we have IC standard for the inverters, for the panel themselves, and for the let's say for all the electrical equipment on the plant. For sure, yes.
All right, thank you for your answer. All right, so there is a question we already talked about anchoring before. I guess a follow-up would be how to hold or how do you hold a floating array during installation before the actual anchoring? I'm sure both of you have experiences in that.
Yeah, I mean that's a very relevant topic, the temporarily anchoring and mooring of the plants, and this is super relevant. Just the analog that I put the clients is the following: you have a boat, and you have a boat with a sail that is open. Do you leave the boat at night without any anchor, just at the mercy of the movement of the water? No, never. Nobody thinks about that. So it's the same in a floating solar plant. If you leave the floating solar plant without the temporary anchoring and mooring, you are buying the tickets for the lottery of a big issue happening to your plant. And I have the conversation with clients, with EPC and installer that they say, well, but look, today it's like a nice day. Why should we start putting the temporary thing that tomorrow I'm going to take out? And it's important to have the temporary anchoring and mooring, but also ballasting the system, because you never know. Usually the temporary anchoring is happening more on the sides, and you can have uplifting winds. And if you don't have a ballast that will keep the floats and the PV panel, you're increasing the risk of problems during installation. So it's important to have a specific program around the use and deployment of temporary anchoring and mooring. Don't skip that part. It's super important.
Mm-hmm. Qussay, you're nodding, so you agree. Yeah. All right. Then we have another question to you, Qussay. In the installation of your 250 project, the one you shared, was it taken into account that the region has already been declared a flood area? It's from Carolina from Fraunhofer.
Yes, actually, we have to say that this flood that never happened like for the past 40 years. So we cannot say that we were 100% expecting something like that, but we were like aware of that this region might have different tide, might have heavy rains in that region. So that's why again I will talk about the distribution or how we organize the cables and how we do have the buoys. And even if it's small area between the AC cables, the connection between the plant and the AC cable point, we still installed some buoys, yellow buoys, to be able to meet with all the tide, the levels of the water. And also we have again the electrical equipment that were based on a floating component that mitigate, that give you the freedom to move in a different tide. So I cannot say that 100% we were considering floods, but we were considering that this region will face some different tides.
Okay, thank you. We have a question following up. So for the FPV design, the question is from Yuhan. What type of solar modules do you use in past projects? So is it bifacial, tracking, or any other kind? I think they'll be interested to listen to both of you.
We have used different type of PV panels, and we usually, again, work together with the client to understand the specific conditions. We have used the traditional backsheet panels and mainly in artificial reservoirs, irrigation reservoirs in areas that are more dry, like in Europe. Imagine the following: the humidity in Singapore when people are walking, it's probably higher than the humidity on top of a reservoir in Europe. So it's the whole, you need to take into account the local conditions. So if you are in an area that is close to the sea, or we have built projects in Colombia that is tropical climate and very, very humid, in those cases, we will work usually with glass-to-glass modules. It can be bifacial or it can be monofacial. Keep in mind that bifacial, there is some gain, but the Solar Research Institute of Singapore has measured the benefit of that extra uh, reflection, but the water is the one that reflects less the sun, because actually you can see through the water. So their numbers, it looks like you shouldn't go for bifacial just because of that reflection. If you can get good pricing for a bifacial module, and if it's glass to glass, go ahead, you can install it. And keep in mind also that that will increase the weight of the plant. So if you're putting that in an area with snow loads, you should also be more careful about that, or also to make sure that there will be enough buoyancy for workers to do all the O&M.
Qussay, same principles
Yes.
or something different?
Yes, indeed. No, the same thing. And also we have been using different types of PV panels. But the thing that constrained the panels, beside what Andreas mentioned, like it's the type of the floaters that we have. We have specific range of dimension, specific like dimensions of PV panels that can be placed on our floaters. And on the other side, we have used bifacial panels. We have also used monofacial panels as well. And also based on the region, like you can see the characteristic of some panels cannot work well in some hot regions, let's say, and some cold regions. So there are many factors that constrain the use of the PV panels.
Okay.
And I think Qussay, what you just said is very, very relevant, and also it's for us it's a important thing to educate our client is the size of the PV panels, and this is something that there is a tendency to try to go for the larger panels, and maybe in utility scale project that you can have machines that are put in the PV panels that works, but think about there will be always movement in the water because of the waves. So if you have a large PV panel, and this is something that companies like Longi have measured, and they don't recommend going for the super big project. PV panels. Because if it's too large, with the movement of the water, there will be some type of bending. And when that is happening many times in a 25 period, and that's why you also don't see a lot of the super big panels in rooftop installations, because also during installation, you only have two people holding the PV panel. And what happens if a light breeze of wind arrives? It's very likely that they will not be able to control it. And it's not exactly they're in the roof, but they're close to the water. So all the installation and O&M costs increase, and especially the fatigue and potential appearance of microcracks. So I think Qussay's point is very relevant, that you also need to look at the maximum size of those PV panels.
All right, thank you both. So we have a final question from Karel Lerna de Winter. So for you, Andreas, who were the installers for the Isigenere FPV plants?
Well, we work with many different type of installers. As I said, we are building this ecosystem of companies that can bring the benefit of floating solar to the end clients. Most of the companies can be big EPC, smaller companies. We will work with them and train them so that they can install the system in a safe way. And depending on the location of the project, we have different partners. If anybody has an interest, they can contact me and we can put you in pass the contact details for them.
All right, and with that, I'm aware that we have reached the end of the webinar. So Q&A, we still have a few questions, but as Andreas has said, you can contact any of the speakers here. So we were joined by Qussay, who is the Doctor of Industrial Engineering, and Polina, who is the CEO and founder of HelioRec. We have Andreas, who is CEO of Isigenere. Yes, if you have any more questions, feel free to contact them, and they'll be more than happy to help you out. They will also be here at the conference that we'll be having in June. So if you would like to join that, we have a discount code up ahead here. So if you want to use this webinar discount code to join us on the 26th of June in Paris to talk about all things floating PV, it's one of my favorite events. It's really practical, really hands-on, and you learn a lot of really cool things. And you get to meet all the great speakers there as well. So with that, we've reached the end of the webinar. Thank you to all our speakers, and thank you for joining us today and for all your really engaging questions. Sorry we couldn't get to all of them. Have a great afternoon. Thank you, everyone.
Thank you.
Thank you, everyone.
Thank you.
Bye-bye.